In late October, the town of Hardwick, Vermont, goes quiet early. The sugar maples along the main road drop their leaves by the second week of the month, and the ridgelines rising on either side of the valley turn the color of wet slate in the long gray light of afternoon. By 8 in the evening, most of the houses on Church Street have gone dark behind their curtained windows. Wood stoves carry the faint smell of birch smoke through chimneys above the roof lines. 2,000 people pressed into a river valley between forested hills settle into the evening, and the night outside their windows belongs to something else entirely. A motion-activated camera mounted above a front porch on that street, one of the wide-angle models people install to watch for package deliveries, captured something in the final weeks of November 2023. The footage shows an ordinary residential block. Bare elm limbs reaching over a concrete sidewalk dusted with early frost. A single amber streetlight throwing a cone of pale light across the road surface. 2 parked vehicles at the curb. A sedan and a pickup truck. The frame holds still for the first 4 seconds of the clip. Then, from the dark gap at the far end of the block, between the last house and the tree line at the edge of a vacant lot, something steps into the light. Long legs, angular at the knee, carrying a body mass that registers as wrong the instant the shape resolves. Not a deer. The shoulder height alone, estimated later at well over 5 feet, rules that out before anything else has time to process. A broad, pendulous muzzle. A pronounced hump of muscle above the front shoulders. A large bull moose walks through the full width of the amber streetlight in 11 seconds, crosses the road at a slow, deliberate pace, passes behind the pickup truck at the curb, and disappears into the dark beyond the far houses. The homeowner called Vermont Fish and Wildlife the following morning. An officer took the report. The description was consistent with a mature bull moose, and moose in Vermont, the officer would have noted, are not classified as rare. The call was logged. No physical response was dispatched. The incident was filed. It would have meant nothing, except that it was not the only one. 6 weeks before the Hardwick footage, in mid-September, a Vermont state police officer responded to a call in Morrisville, a village of roughly 2,000 people set along the Lamar River, 18 miles to the west. Residents had reported a moose standing in the parking lot of a laundromat on Elmore Street at 10:30 at night. The animal stood motionless between 2 parked minivans for approximately 20 minutes, then walked north through a gap between 2 houses and disappeared into the dark. An officer confirmed the sighting. No documentation of the animal's body condition or apparent health was made. In St. Johnsbury, the largest town in Vermont's Northeast Kingdom, and a working-class community of around 7,000 residents, set below forested hills in the Connecticut River watershed, a trail camera mounted at the back edge of a residential property recorded a cow moose and her yearling calf crossing between backyards on 3 consecutive nights in October 2022. Same corridor between the same 2 houses. Same time window. Between midnight and 2 in the morning. 3 nights, 3 crossings. The same route walked with a consistency that suggested familiarity rather than accident. In Montpelier, the state capital, a bull moose walked the full length of State Street in the early hours of a January morning in 2023. State Street is the central spine of Vermont's seat of government, flanked on both sides by brick office buildings, a coffee shop, a pharmacy, a city park with bare-limbed trees in an iron fence. The moose moved past darkened storefronts and traffic signals for several blocks before officers arrived and redirected it toward the Winooski River floodplain on the city's northern edge. In Stowe, a ski resort village whose historic downtown sits directly below a steep wall of wooded terrain, documented encounters between moose and people near hotel parking lots and restaurant service entrances became frequent enough over the 2023 to 2024 season that Vermont Fish and Wildlife issued a formal public advisory. The advisory urged residents not to approach moose on foot, not to leave garden waste or mineral-based soil amendments outdoors, and to call dispatch immediately if an animal appeared disoriented or failed to move away from approaching humans. That last detail is worth keeping in mind. 1 sighting is an anecdote. 7 is a pattern. The documented reports of moose entering Vermont town centers at night span not one county, but the entire northern half of the state, from the Champlain Valley foothills west of Burlington to the Connecticut River drainage along the New Hampshire border. From Lamoille County in the north-central region to the edge of Orange County to the south. The geographic reach of these incidents is not consistent with a single disoriented animal or a localized habitat problem. Something is moving moose into residential streets, under streetlights, through parking lots, past porch cameras, with a regularity that incident records alone cannot fully account for. And whatever it is doing this consistently, after dark. To understand why that matters, you need to understand what a moose actually is, not in the way you half remember from a school field trip, but in terms of physical scale and ecological position. Alces americanus, the eastern moose, is the largest member of the family Cervidae in North America. Adult bulls in Vermont typically weigh between 800 and 1,200 pounds. The heaviest documented individuals in the northeastern subspecies approach 1,400 pounds. At the shoulder, a mature bull stands between 5.5 and 6.5 feet tall, taller than most interior doorways. The antlers of a fully developed animal span 4 to 5 feet across. A moose can sustain a trot of 30 miles per hour over flat ground. In deep snow, those long legs provide a mechanical advantage over most predators. In open water, they swim comfortably across rivers and lakes several miles wide. In dense boreal forest, a moose standing still in a stand of black spruce at 30 feet is, counterintuitively, close to invisible. The dark pelage, the broken silhouette of the antlers against broken light, the complete absence of reflective surface, combine to make an animal the size of a small car effectively undetectable at close range. Vermont's statewide moose population, according to Vermont Fish and Wildlife Department estimates, currently sits at approximately 3,000 animals, concentrated primarily in Essex, Orleans, and Caledonia counties in the northeastern corner of the state. This represents a steep decline from the early 2000s, when the same population was estimated at close to 5,000 individuals. The agency attributes this decline to two compounding biological pressures. We will get to what those are, because they turn out to be essential to what is happening in these towns at night. The behavioral baseline for this animal, as described in field research from Vermont, New Hampshire, and Ontario, includes the following: deep forest cover through the winter months, wetland and riparian margins in summer, movement along stream corridors and ridgelines during dispersal. Adult resident moose hold home ranges of 12 to 40 square miles. What they do not typically do, as a documented species norm, is enter the centers of human settlements, navigate parking lots between parked vehicles, cross residential intersections at midnight, or return to the same urban corridor across consecutive evenings. When that baseline breaks, it does not break without reason. Vermont is a compact state, 986 miles across at its widest point, and an unusually forested one. Approximately 78% of Vermont's roughly 9,000 square miles of total territory is tree-covered, compared to a national average for the contiguous United States of approximately 33%. Drive the two-lane county roads linking the small towns of the Northeast Kingdom, from Hardwick to Cabot, from Lindenville to Island Pond, from Barton to Glover, and the forest comes directly to both sides of the road, with no transition. No gradual suburban fade of strip malls and housing developments. A moose standing in old-growth spruce fir in Essex County can be a quarter mile from a lit residential street without crossing anything more significant than a gravel road. But that boundary between moose habitat and human settlement has not remained fixed over time. Vermont's land use data shows a gradual encroachment of residential and commercial development along river corridors and town edges over the past 3 decades, particularly in the transitional zones between agricultural clearings and forest margins. At the same time, habitat quality within the boreal interior has declined in ways that are independent of development. Warmer average temperatures, documented consistently in Burlington Climate Station records dating to the 1960s, have altered the plant communities that moose depend on for winter browse. Balsam fir regeneration in the southern portions of Moose Range has declined. The habitat is not only smaller in some areas. In some areas, it is less able to sustain the animals that historically used it. A moose moving away from degraded or parasitized habitat does not consult a map. It follows food, water, and mineral gradients through the landscape. In Vermont, those gradients increasingly lead toward the road salt residue, the garden soil amendments, and the unintentional mineral concentrations that human settlements leave along their edges. A moose following a gradient does not stop at a town boundary sign. If you have made it this far, subscribe. This channel covers the cases that field science has not yet fully closed, and this is one of them. There are at least 3 documented mechanisms that could explain the behavior being recorded in Vermont's towns, and taken individually, not one of them is exotic. Together they describe a situation that wildlife managers in the Northeast are only beginning to fully map. The first is road salt. Sodium chloride spread across Vermont's roads and town streets through the course of a typical winter leaves a mineral residue that persists in roadside soil and drainage ditches well into spring and summer. Moose, like most large ungulates, have a documented physiological requirement for dietary sodium that exceeds what most inland boreal forest habitats naturally supply. Research published in ALCES, the primary scientific journal for moose biology in North America, has documented road salt as a significant behavioral attractant for moose across northeastern North America, sufficient to alter daily movement patterns and draw individual animals repeatedly to the same roadside locations. A moose following a sodium gradient from a mineral-poor spruce bog to the salt residue along a plowed residential sidewalk is not behaving randomly. It is solving a nutritional deficiency with the most available resource in its immediate environment. The town, in that calculus, is not a destination. It is a mineral lick with streetlights. The second mechanism, and the one that concerns Vermont wildlife managers most directly, is brainworm. Paralophostrorhynchus tenuis is a parasitic nematode, a roundworm, that white-tailed deer carry throughout their eastern range without experiencing any clinically apparent symptoms. The parasite completes part of its life cycle through microscopic terrestrial gastropods, common garden slugs and land snails, which deer ingest incidentally while grazing. In deer, the organism causes no measurable neurological damage. In moose, the outcome is categorically different. Once established in a moose host, the worm migrates to the spinal cord and brain tissue, where it progressively disrupts the neurological pathways governing spatial orientation, threat perception, and basic behavioral regulation. Early infection produces subtle changes, slight incoordination, a reduced startle response at close approach. As the infestation progresses over weeks, the degradation accelerates. Affected moose lose the capacity to process threat signals in the normal way. They stand in exposed open areas they would ordinarily avoid. They fail to react to approaching vehicles, approaching humans, approaching noise. They circle in place. They move towards stimulation rather than away from it. The behavioral profile of a moose in the advanced stages of brainworm infection matches with a precision that experienced Vermont wildlife officers have noted in field reports. The behavioral profile of the moose appearing in the state's town centers, standing motionless in a parking lot between 2 minivans for 20 minutes, walking past lit storefronts without changing pace, crossing the same residential corridor across 3 consecutive nights as though the route had been learned. White-tailed deer have extended their range steadily northward into Vermont over the past 3 decades, driven by milder winters and the expansion of agricultural land and early successional brush in the northern counties. As deer move into territory that moose historically occupied without competition, they carry Paralophostrorhynchus tenuis with them. The parasite follows the deer range expansion like a shadow moving behind a figure. If you have walked a Vermont trail during the October deer season and later found a tick on your jacket, you have briefly shared the same landscape that this transmission chain moves through on its way to moose brain tissue. The third mechanism is what happens when a declining population produces more dispersing individuals than the available habitat can absorb. Vermont's moose numbers have dropped by approximately 40% since their early 2000s peak. Fewer resident adults mean that more dispersing yearling bulls, Animals in their first autumn, away from their mothers, must travel farther and cross more terrain in search of unoccupied territory. A dispersing yearling moose in poor body condition, carrying a winter tick burden from the previous season, following sodium gradients along road corridors through September and October, can cover 40 to 60 miles in a matter of days. When it reaches the edge of a town, it does not stop because the terrain looks human. It stops because it has reached something that its biology has been directing it toward all along. This has happened before, not with moose specifically, but with the underlying pattern: large wild animals reconfiguring their relationship with human settlement in ways that biologists initially classify as aberrant before recognizing them as the early signal of something structural. Black bears in Asheville, North Carolina began appearing in residential neighborhoods with reliable frequency in the 1990s. By 2015, researchers tracking Asheville's urban bear population had established that certain individuals were not straying into the city in desperate search of emergency calories. They had restructured their home ranges around human food sources, compost bins, bird feeders, and unsecured garbage cans in patterns that bore almost no resemblance to the rural bear behavior described in prior field literature. They were not lost. They had reorganized their ecology around a new resource distribution, and the reorganization held. The urban coyote case is even more precisely documented. Stanley Garrett at Ohio State University has led one of the longest-running urban wildlife tracking programs in North American research history, following coyotes in the Chicago metropolitan area through GPS collaring that began in the early 2000s. What Garrett and his team documented was not a population of rural animals wandering into city limits by mistake. It was a functionally urban population that had developed behavioral adaptations specific to city life: smaller home ranges than rural relatives, dramatically altered diet composition, and movement schedules calibrated almost entirely around human activity patterns. Chicago's urban coyotes moved primarily between midnight and 4 in the morning, not because coyotes are inherently nocturnal, but because that time window corresponded to the lowest density of human foot traffic on the city's residential blocks. The animals had learned the city's temporal rhythms and adjusted accordingly. Over generations, mountain lions in California's Santa Cruz Mountains, along the Colorado Front Range, and near residential developments bordering the Jemez Mountains in New Mexico have been documented approaching developed areas with increasing proximity over the past decade. Not because puma populations have expanded, but because the wildland-urban interface has contracted. California Department of Fish and Wildlife incident data from 2015 to 2023 shows a pattern of proximity events between mountain lions and residential edges that is now treated as a subject of formal management planning, not as a series of unrelated anomalies. In every case, the trajectory follows the same arc. Individual incidents read as curiosities. Reports accumulate across a geographic spread. Recognition arrives, delayed but eventually, that something structural in the landscape or in the animal's circumstances has changed, and the change is expressing itself first in behavior at the margins where wild land meets settled land. The moose appearing in Vermont's towns at night are at an early point on that arc. Whether this resolves as habitat pressures ease or deepens as the conditions driving it continue, the available data cannot yet say. Honesty requires saying plainly what the skeptics get right. Moose in Vermont encounter humans near forest edges as a matter of routine. State Route 2 through Caledonia County, the road linking St. Johnsbury to Montpelier, produces multiple moose vehicle collision reports every winter. Vermont towns are built inside moose habitat, not adjacent to it, and some fraction of what gets logged as unusual behavior is probably the ordinary range expression of a large animal whose geographic territory overlaps substantially with human settlement. A moose at the edge of a parking lot is not, by itself, evidence of a crisis. The skeptic is right to say so. But the skeptic's position runs into 3 specific problems, and not one of them requires the pattern to be something other than what the incident records describe. The first problem is coverage. Vermont Fish and Wildlife manages approximately 3,000 moose across 9,000 square miles of landscape. The department's formal monitoring capacity, its aerial survey routes, its GPS collar program, its seasonal camera deployments, covers a fraction of that terrain in any given year. The overwhelming majority of Vermont's moose move through landscape that is never formally observed by anyone positioned to record what they see. What enters the incident log is what intersects with a human observer in a place where humans happen to be. The absence of evidence, in almost every case, is the absence of people positioned to observe. The coverage does not exist to tell us what is moving through the dark in the thousands of square miles where no one is watching. The second problem is classification. When a moose enters a Vermont town, the event becomes a nuisance wildlife dispatch call. It is handled by whoever is available, resolved when the animal moves on or is redirected, and recorded as a single line in a call log. The data that would allow a researcher to determine whether the same individual is appearing in the same town across multiple nights, whether animals entering residential areas show different body condition profiles than the surrounding population, whether brainworm case geography correlates with proximity to human settlement, does not exist in any usable analytical form. Events that should generate research questions generate dispatch entries instead. The classification system filters out the signal before anyone can study it. The third problem is biology. A moose in the advanced stages of brainworm infestation does not remain available for examination. The progression from first observable neurological symptoms to mortality, in documented field cases from New Hampshire and Vermont wildlife records, unfolds over a matter of weeks. An animal that appears disoriented in a laundromat parking lot on a Tuesday evening is likely to be struck by a vehicle, euthanized for public safety, or dead from physiological stress before any systematic documentation can be gathered. The evidence dissolves with the animal that generated it. There are no bodies left behind in any form that links them to the incidents that preceded their presence in a town. The answer to what is happening in Vermont's towns at night comes in pieces, and not one of those pieces requires the behavior to be impossible, or beyond the explanatory reach of what field biologists already know about this animal and this landscape. The porch camera in Hardwick recorded nothing after that November night. The homeowner extracted a still frame from the 11-second clip and posted it to a local community forum the following morning. 34 comments accumulated over the next several hours. People asked whether anyone else had seen it. Someone suggested calling the warden service. Someone noted that this was Vermont and this kind of thing happened. The thread went quiet within 2 days. The footage was not submitted to Vermont Fish and Wildlife as part of any formal monitoring program. The animal was not tracked. The event was absorbed back into the texture of daily life in a small New England town, which is almost certainly how most of these incidents end, not with investigation. With absorption. There are roughly 3,000 moose distributed across Vermont's northern counties at any given moment. Some of them are healthy animals operating well within the behavioral parameters that wildlife managers use to describe this species. Some of them are carrying a parasite that gradually dismantles the neurological architecture that tells an animal where it belongs and where it does not. Some of them are young bulls in the middle of crossing 50 miles of Vermont landscape in a season, following sodium gradients along plowed roads and water corridors between dark forested ridgelines. Any one of them can walk through a residential block, cross under an amber streetlight, pass a porch camera at a slow and deliberate walk, and disappear back into the dark on the far side of town without leaving anything behind that settles the question. What the camera caught in Hardwick was not evidence of ecological collapse. It was not proof of a crisis. It was something quieter than either of those framings, and in some respects stranger. A large, complicated animal whose biology is under pressure from multiple converging directions, passing through a human place at night. For reasons that are individually plausible, collectively unresolved, and in all likelihood continuing right now, in towns across northern Vermont, in the hours after midnight when the residential streets go empty and the streetlights cast their amber circles on the frost. The footage was 11 seconds long. The question it asks has been accumulating for years.